so, boy, do I love chapter 8. Okay, so today we're going to use some new vocab terms, and I swear if you can get these vocab terms down from this first section, the rest of chapter 7 is going to be pretty easy, because a lot of the questions on the test will say words like ratio, proportion, scale factor. And if you learn after today what those words mean, you'll be able to set up each problem. Okay, so to start with, a ratio is a comparison of two quantities using division. That's a fancy way of saying a ratio. When I think of a ratio, I think of a fraction. When I think of a ratio, I think of a fraction. So if I were a highlighter or a color or whatever, ratio is the first word. You're really going to need this chapter. Okay, and so it continues to say the ratio of quantities A and B can be expressed A to B, A with some dashes like a colon B, or A over B, which is how we mostly express it, as a fraction. And like any other fraction, if you've read my 10 rules of math over there, the main rule is that you cannot divide by 0. So B can't be 0. Okay, and then when we have a fraction, what do we want it in? Like, we don't want 3/6. Why is that? What's wrong with it? We would rather have 1/2. Why is that? What's that called? Yeah, so we're wanting it in simplest form. Thank you, dear. So this sounds silly, but on this next test, you could potentially get counted off. Not much, but a little. Harrison just lost a point if he left it at 3/6 rather than reducing to 1/2. Okay, and then if you wanted to be really fancy, and we don't do this a whole lot, but there are a couple examples with this. An extended ratio, and I'm not even going to highlight it because it doesn't come up that often. An extended ratio has an I, Ms. Compton. An extended ratio can be used to compare 3 or more quantities. And I said we don't really use it, and we do a lot with triangles. So 3, 4, 5 would mean it's telling you 3 things all at once. It's telling you 3 to 4 with those two. It's telling you 4 to 5 with the middle one and the last one. And then it's also telling you 3 to 5. It's telling you 3 fractions all at once. Now, are you supposed to remember those 3 fractions all at once? No. I'm just telling you what it means. And on most of the word problems we do, they don't tend to say extended ratio. So if you wanted to block extended ratio out of your brain, it wouldn't hurt my feelings. Okay, so we have quite a few examples, and sadly, what you're not going to like about this section, you like fractions that you can handle, but most of the problems, as you can see from our first 4 examples, involve words. It's not just straight up math. So, we're in a word problem section. The first problem says, I'll get someone else to read, I'm tired of reading. Riley, don't you like to read? You seem like you like to read. Elena, do you like to read? Who likes to read? Ayana, you must like to read. Can you read number 1? I'm tired of talking.
In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio at a school?
Okay, again, the key word we're looking for in problems right now is what? What word do you see up there that I need? It's the important one from this section. Ratio. So I need to know student to teacher. So who needs to be on top, student or teacher? Student, because it says student to teacher. And of course we could write this with the student and the colon teacher. We could write this lots of other ways. I tend to just go straight to the fraction because that's how most people see it. Okay, what number do I need to plug in for the students? Okay, 2,650. What number do I plug in for the teachers? 190. And then if we reduce that, because they each have a 0 on the end, the answer is 265 over 19. I'm not really looking for a decimal. If you give me a decimal, I won't be mad, but I would rather see a fraction like this. Okay? So what could happen is Catherine could misread this word problem. She could see teacher student, and she could have her fraction flip. She could have the 190 on top and the 2650 on bottom. And that's going to get her counted off a little bit of points because she technically didn't read through the whole problem. Not much, but a little. Okay. Ellie, do you like to read? Will you read number 2?
A baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks.
Okay, stop right there. So what are we looking for? What ratio? I see the word ratio. Number of base hits to the number of at-bats. So we want base hits on top to the number of at-bats. And hopefully once we let Ellie start reading in, we'll have some numbers to plug in. Okay, go ahead, Ellie.
Minnesota Twins Joe
Mauer.
had the highest batting average in the Major League Baseball.
It should be 2006. I know 3006 hasn't happened.
If he had 521 official at-bat hits and 181 hits, find his batting average.
Okay, so I know that Gage plays baseball. I assume there are other baseball players in this room. Okay, so his base hits, what number do I put in the numerator?
181.
What number do I put in the denominator?
521.
Okay, so I could look into reducing this fraction, but tell me, Gage, when we talk about someone's batting average, do you want a fraction? What do you want? A decimal. So in this case, for this example, because it says batting average, I know I actually want a decimal. So I need someone to type 181 over 521 in their calculator, and let's get a decimal.
0.347.
Okay. Unless the problem specifies, this is just a general rule that Miss Compton uses, and you should probably. I go to 3 decimal places. Okay, and then you knew eventually we were somehow going to relate this somehow to geometry. So the next one asks about a triangle. And since I love triangles so much, I will read it. The ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Okay. Any suggestions on what I should do?
3 over 4, 4 over 5, and 5.
I could do that. And I could do that. I could do that. I'm going to draw me a picture. And I was going to put 3, 4, 5, but that's silly. That's not right. That only adds up to 12. This needs to add up to 180. So there's something wrong with my picture already. I'm going to put an X next to all of them. What should my angles add up to in a triangle?
180.
180. So I'm not even... Ayana and Derek were trying to suggest how to use that extended ratio I mentioned at the beginning. I don't even use that. I just set it up like we normally would. 3x plus 4x plus 5x equals 180. Now, I'm sure they could get the answer using their way, but this way just seems the easiest. So 12x equals 180. I don't know what x equals. 15. Now, if I was mad at you about anything, it would be on the tests. You didn't. What I told you not to do, some of us did it. You get the answer of x equals 15, but that's not the for real answer. They asked for the measures of the angles, so we need to plug it in for each of the angles. 3 times 15, 4 times 15, and 5 times 15. And if I was really trying to get the A in geometry, which a lot of us really truly are, I would add up those 3 numbers and make sure they didn't make 180, because I always like to check myself. Are there any questions about this? Okay, then I need someone to read the next one. Gage, can you read number 4?
In a triangle, the ratio of the measures of the side is 2 to 3, and the perimeter is 392 inches. Find the length of the sides of the triangle.
Okay, so I always like to draw me a picture. Here's my picture. Do I put the 2, where do I put it? Where do I put, I want to put a 2 and a 2 and a 3 somewhere. Where do I put them? On the sides of the triangle. So in the last problem we were talking about angles. This problem we're talking about sides. So please don't get that confused. Okay, are the sides supposed to add up to 180? No, sides don't add up to 180. In fact, that's why they had to tell us the perimeter. The sides are supposed to add up to 392 inches. So I need to do 2x plus 2x plus 3x equals 392. So I get 7x equals 392. So x equals some number. What is it, 56? Okay, and then, but again, it didn't say find x. It said find the length of these sides. So I have to plug it in. So 2 times 56 and 3 times 56. I think that's 112. I don't know that.
That's 112.
What's the other one?
168.
168. Okay, and Miss Compton only bothered to do that. I get that 2 of the sides are both 112. So if I had to make a list of the 3 sides, it'd be 112, 112, and 168. And again, if I'm trying to make sure that I've done everything right and I can solve correctly, because we all make algebra mistakes, that's life, I could add up 112, 112, and 168 and make sure they add up to 392, because that was what the perimeter was supposed to be. Okay, so let's flip. So I told you this section is all about, did everyone get that? This section is all about vocab terms. So the first vocab term you've got to know is ratio, which really means we're looking for a fraction. And then the second vocab term that you need to know is proportion. So if we have 2 equivalent ratios, they're called a proportion. So that sounds like really fancy math. In normal English, if you have 2 fractions and an equal to sign, if you have a fraction equals fraction, that's called a proportion. Okay. And to solve a proportion, we use some property, and it's called this cross product property. And they make it sound really complicated, and they call some things the extremes and some things the means. But really I'm just looking at the 2 diagonals. So I see this diagonal, A and D. They call that one the extreme if you're interested. I see this diagonal, C and B. They call that one the means in math. I don't know why. They just do. And so we cross multiply on the diagonals. So I would do, if we were doing math with letters, I would do A times D equals C times B. It's going to be a lot easier once we start using numbers with it. But the point is, if you have a fraction equals 2 fraction, all you have to do is multiply on the diagonals. Okay, so for instance, I'm going to make an extra example. If I had 2 over 3 equals x over 6, I would multiply on the diagonal, so I would have 12 equals 3x. I divide both sides by 3 and I get 4 equals x. Are there any questions about the cross multiplying? Okay, then let's go ahead and try number 5. Try it really fast. Raise your hand if you got an answer. Not Derek, but anyone else has got an answer for me. I want you to leave it as a fraction and hopefully a reduced fraction.
This picture on my test.
Uh-huh.
She goes, okay. Well, I found out that I have borderline diabetes yesterday,
Oh my goodness.
and so I gotta do something about it before I really got it.
But you were doing so much better.
I am, yeah. But it was just from last year we stress eating because of that probation and everything. So I did reduce
How many of those? Just one?
one a day.
Okay. I see that.
Oh yeah, I lost 6 pounds too.
Look at you. Okay, can someone at least tell me the first step? What did you get when you cross multiplied? Negative 6x equals what? Perfect. So, because it was 4 times 11, for those who need that extra step, that's how we got 44. So negative 6x equals 44. And if you divide both sides by negative 6, you get x equals negative 44 over 6. But we need to reduce that fraction to what? Okay, because both the numerator and the denominator are divisible by 2. Now again, if you stink at reducing fractions, my suggestion to you is on the last step, make it a decimal, unless the problem says it must be a fraction. Now I'd rather see fractions, but if you don't know how to do that step, I can let it go. Okay, so let's see. Oh, I got plenty of time. Let's go ahead and we'll do 6 and 7, and then we'll leave some of the fun stuff for tomorrow. The 6, when I cross multiply on the diagonals, the first diagonal is easy. It's the second diagonal that I have a problem with. So on the first diagonal, 6 times 7, well, that's 42. But on the second diagonal, I have a 4, and I have 2x plus 5. So they started making it a little harder. Now I'm going to have to actually solve and distribute, and it's becoming more of an algebra issue for me. So 4 times 2 is 8, 4 times 5 is 20. If I subtract 20 from both sides, I would have 22 equals 8x. I would write that, but I wrote too big today. When I divide both sides by 8, I have 22 over 8 equals x. But that's not as simple as I can go. So I need to reduce that to 11 over 4. Okay, let me go back over that one because that one's a doozy. So it's still exactly what we were doing on number 5. I multiply the one diagonal, I multiply the other diagonal. 6 times 7, that was easy. That's just 42. It's the other diagonal that's the issue. You do 4 times 2x plus 5. But because of that, you have to distribute the 4 to the 2x, and you have to distribute the 4 to the 5. So it makes life a little more complicated. Are there any questions about that one? Okay, and then if you thought that wasn't enough, at least on this example, the one diagonal was easy because 6 and 7, we could do that. It was pretty easy. But then on this last example, my gosh, they did 9 and x minus 1, and they did 7 and x plus 4. Are they crazy? We have to do both of them that way. So I distribute, and I get 9x minus 9 equals 7x plus 28. If I subtract 7x, I get 2x minus 9 equals 28. If I add 9 to both sides, I get 2x equals 37. So x is 37 over 2. Okay, so I'm going to go ahead and give you what I was going to give you tomorrow if you want to go ahead and practice some of these cross products and such. The worksheet I'm going to hand you is so tiny you're going to need to write on your own paper. I've not gone over the bottom 3. I'm going to hit on those tomorrow, and then I'm going to let you work on your worksheet during class. But if you were wanting to go ahead and get a head start, because some of us, it takes a few minutes, takes me a few minutes, you could. The next part, what we're going to talk about tomorrow, is really what I think is the most useful for real life, because if you're interested in like architecture or graphic design or engineering, you need to know about how to make models, like my Eiffel Tower model. Okay. If for some reason you did not finish your test yesterday, or there's something you're supposed